We are live. Should we wait for someone or should we start?
We should probably get started. I'll ping Jarish just to see if he's.
All right. Welcome, everyone. This is the May 27, 2020 Diagnostics Deep Dive meeting. We are going to be discussing the last one of the performance use cases. As the last time we discussed reducing cost for memory-bound applications. And this week we are going to be discussing my application has a poor performance use case. So when we were brainstorming the use cases, we come up with this one, and we described the symptoms for it as my application's latency is high, and I have already confirmed that the bottleneck is not my dependencies, like databases or downstream services. So I suspect that my application is spending significant time running code or processing information. You are satisfied with your application performance in general, but would like to understand which part of your application can be improved to run faster or more efficiently. It can be useful when we want to improve the user experience or save computational cost. So wait. There is a disconnect between the list of use cases and the headers we have. Like the header here is my application has a poor performance, but I don't see a lot of difference between this and the other two use cases we already had. But in the list of use cases in the first page, the third use case is my application shows spikes of CPU usage. So maybe we did something wrong in the doc.
Can you just scroll up? What was or paste the link to the, or maybe that's what you already did. Okay, never mind, got it.
Okay.
I'm just looking to see.
Are you saying that this one and the first one is the same or what? Sorry.
Yeah, this one that I just read is basically the same as the first two that we already discussed. It's a merge of those two. So I think it was from a past iteration of this document and it should be removed. The use case that we are going to be discussing today is performance spikes or growth slowness over time, which are different than, for example, constant performance problems.
Yeah, that makes sense.
Can you please ping me the link to the document?
Or I'll just repaste in the chat for the, no, that's the wrong one. Sorry, Mateus got it.
All right, so what are the symptoms for spikes or slowness over time?
Application is responsive, temporary. high latency temporary?
Yes, high latency temporarily. Which can be either like for a few minutes or a few seconds. So if it's a small duration that the spike happens, you might see it as a increased latency sometimes on P99 requests.
Now, the thing that makes me think, like, I don't think any of the previous sections we covered latency at all, did we? It was mostly investigating either memory or CPU. That may be where some of, so go ahead.
We did mention latency as a symptom.
Right, but in terms of debugging the problem, like I think that's where like that description that we'd written was trying to get at the latency part versus the CPU part. Just since you're mentioning latency, maybe we should come back to that after we get through this. But
yeah,
like, I don't think we've talked about any tools for looking at the event loop latency or anything like that.
Yeah, I think that's a good topic to cover next after we finish this use case.
Sure.
Or maybe even as part of this use case, because
Yep.
it's somewhat related to performance.
What about the unresponsiveness? Is there just another way of saying latency, or like when you compute a timeout request, or like?
I think that's possibly the extreme case of the latency so long that you then start timing out, or
Any other symptoms people can look?
well, the title says spikes of CPU usage, so we kind of miss the symptoms. Like maybe that title needs to be more, we have intermittent performance issues, right? Which could be,
yes.
And then like a symptom would be spikes of CPU usage, perhaps.
So I changed the title to my application has intermittent performance issues or growing slowness over time.
Maybe or it gets slower over time.
Yes. So yes, one symptom can be CPU spikes. Any other symptoms?
So here, by and large, when we say latency, we are essentially meaning delay in the transaction or the responsiveness, not necessarily the latency in internal components like UV loop or any other runtimes activity. It's an externally visible delay in some of the user-initiated process. Am I right?
Sorry, can you repeat?
When we say latency, it is a visible delay from a user's perspective on some of the activities which they initiated. For example, a web transaction takes more time than expected, as opposed to a latency that is internally measurable, like UV loop or anything which is an internal component. We are not talking about that. We are talking about an external web-based transactional latency. Am I correct?
I don't think it has to be web-based necessarily, but I would agree that the use cases you're seeing intermittent cases where, you know, the response that you expect in terms of latency is higher than you expect. Whether it's a web service, a web page, some other sort of call.
Yeah, makes sense. In either case, the latency is something which is perceived by the end user through some of his tools.
Yeah, now that's where we are mixing in the symptoms. Like CPU spikes isn't necessarily going to be a symptom that the end user sees, but it is a symptom you can see if you look at your system. And in that context, like a longer event loop latency would be something you might, might be a symptom on your system. So I guess it's, I don't know if you're leading towards the question being, should those symptoms strictly be the external ones or things like CPU spikes or whatever is I don't know if that was the question.
Yeah. My point is, when you say you have a performance issue, you could actually experience the performance issue in two broader categories. One is that you see the throughput is reduced, that is the operations per second or whatever parameters you use is substandard or suboptimal. Second one is the overall efficiency looks good, but there are actions which are taking longer time than expected. So then this need to be qualified better. You employ some tools like CPU profiles or some graphs which has time in the x-axis. And eventually you start seeing the spikes and other things. So the latency would map from external perspective as well as internal. If you're using tools will show internal component level granularity, whereas if you are not using the low level tools but the application specific tools, you will see the transaction or the user level operation specific latency.
Right, but when we start to employ those tools, we are at the debugging stage, right?
Yeah.
We are still listing symptoms.
Right, and the symptoms, it might be like high request latency if the point is to qualify which latency.
I would vote on the user symptoms.
Yeah, that makes that is more relatable to the user. I agree.
Similarly, it could be increase in request timeouts.
So CPU spikes shouldn't be here, if I understand correctly.
I think
it should be in the debugging.
Yeah.
Okay. Any other symptoms that we have in mind?
Not that I can think about.
Is there any symptoms that we can observe on non-web servers? For example, on bundlers, maybe?
I mean, I think the latency can be interpreted in a very general way. Like if it's some kind of asynchronous queue processing system, then not necessarily would call latency. It would be time to handle the package, but I guess that's basically the same. That's the latency of the system, I guess.
Yeah, and things like, I think you said bundlers, like so command line programs. I'm not sure that they're like, you often see intermittent performance issues. It's more like I ran it and it just didn't do what I wanted fast enough.
I agree. Okay, so if we remember any other symptoms, we can come back. For now, let's advance to debugging. As you already discussed, CPU spikes is something that can be observed to confirm that we have an intermittent performance issue. So to check for CPU spikes, you should sample CPU usage over time and look out for CPU spikes.
Yep.
This can be done with tools like Prometheus, or, well, there are many tools that you can use to sample CPU usage.
But I guess there are a bunch of different tools, but it's, in terms of our recommendations, I wonder if, like, those can be very hard things to do if you don't have instrumentation in beforehand, right? So it's kind of like, I wonder if our recommendations should be to prepare, you should always be outputting metrics through things like Prometheus, or, you know, something that you don't have to go and turn on when you decide there's a problem, but that are there and you can use.
So I wonder if we should have a document of everything that the project recommends to prepare before going to production.
Mm-hmm.
And I'm not even thinking this limited to diagnostics, but something broader that we should have in the Node.js website.
I think that'd be good, although I think we should maybe write it first for what it looks like for diagnostics.
Yep, I agree.
Because that would be enough of a scope. And I'm pretty sure, like, Jarish, in some of the sections we had that, right? Like for core dumps, we included the, we recommend you do X, Y, and Z to make sure like your UMasks are set correctly, or not your UMasks, but your ulimits are set correctly, and that like you have enough disk space. So I think that would be consistent, like for this section. And then maybe we should pull all those out into like just a one consolidated document at some point that says, here's all the things we recommend you do. And then they can have the links back to the sections that actually talk about the debugging and why you need those things, right?
You mean to say consolidate all the preparatory phase activities, all the prerequisites, irrespective of the symptoms, put everything together and put it into one document.
Yeah, but like, I think that stuff belongs nicely with the sections that explain, I think if I look at crash, is it the read? No, there was one that you'd already written. Where was it? Normal termination.
Yeah.
And then at the bottom, there's, where was that? In there was definitely a setup.md, right?
Yeah.
And so I think, like, I don't think we'd want to pull all of that into one common place, but having one common place that then refers to them all. It says, hey, we recommend you set up blah, 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 just a very high level. And here's the instructions for how you set up in each of the sections. Something like that would probably be quite useful.
Yeah, that makes sense. And we can actually provide sections to say that this is for crash diagnostics, this is for performance diagnostics and things like that.
Right, because this one right here is, here, I'm just going to paste it, is the one that you wrote earlier. I just posted that in the chat. That was related to, well, what are you going to need to be able to have in place for abnormal termination? So we should write a similar setup in each of these sections, like, okay, what is it that we suggest you have in place already?
Yeah, the only confusion, the only concern is that it might deviate from the original directory structure which we decided, which is okay.
I'm just like an additional file that pulls that all together. So if you look at a particular section, you still have the setup MD, just like the structure we had. But separately, there could be like something that is a reference to all of those, just to say, hey, if you're setting up a system so that you can do any one of these things when you need to, this is the master list of what we think you should set up, and it's just references to the actual files that has the details.
That makes sense, because for a production, the user will be interested to make sure the system is prepared against all the symptoms, as opposed to he cannot foresee that his application is going to be vulnerable only for crash. So that makes sense. Yeah.
Sounds good.
Yep.
It's something that we can do asynchronously though. In the repository.
Yep.
Since we already bring up these setups in the debugging section, so you just have to pull from the document and aggregate there.
Yes.
Sounds good. Okay, coming back to debugging.
Because the other thing you're going to need in that situation is you want to be able to look at the the traffic or what kind of requests you're getting. Like in the abstract sense, you want to know how much load, external load there is on the system, because is it just slow because you've got a lot of traffic, or is something else going on, right?
I agree.
Like, in fact, I would almost put that as the first one. Right, like my very first question would be, okay, it's slow at some intervals. What's special about those intervals, right? Is it that there's more traffic? Are there a different mix of certain transactions?
Does it make sense? Understand the requests that are coming, which paths they're hitting, HTTP
Yep.
methods, payload size, if there's any difference in the error frequency.
Yep. Those are all things I think you mentioned Prometheus, but that's like, if you've got your app, if you either have, if you're either exporting those through Prometheus or you're getting them through some other APM type
Yes.
solution, that's probably what you're going to need. I think Prometheus is kind of the standard if you're not, buying a service.
Yeah, Prometheus is quite popular. There is another one that I don't remember the name right now. It was popular a few years ago. I'm not sure if it still is.
I guess separately, there's also things like Jaeger and Open. It's not Open Tracing anymore, but Open AP. So go ahead.
Open Telemetry.
Open Telemetry. That's it, right?
Sorry,
yeah, which you were participating in, right? So.
Me?
I
was participating, but only at the beginning.
Right. Okay. I think that's the other sort of monitoring that would help in this situation too, like, because it's helping you. That helps you break down where in the overall transaction flow.
I just got back. I was out in the last 5 minutes. I'm just reading the note.
Okay.
Yeah, I don't know. I don't have a context. Just continue. Sorry.
Sorry, we were just talking about like how you would investigate these, intermittent. And I was saying, like, my first question is like, what's going on that's unique about those intervals?
So the tracing is definitely a good solution to confirm that it's not the downstream service and it's not the database, and so it's not your dependencies.
Right.
So it's not going to help you in the process, but it's going to help you to kind of narrow down to your own process the problem.
Right. Okay. So maybe that's a pre-step is to somewhere it's good to cover, like, okay, how do I figure out which component is causing the problem if I have multiple requests?
Yep.
But this one in particular could be, hey, I've already narrowed it down to this component.
I don't think that tracing will help with that.
Right. Once you've already narrowed it down to this component, then open tracing is no longer the solution, right? Yeah. So we just want to cover it somewhere, and I think you were maybe thinking it could be a separate part of the. It might be another different step, or maybe it's just a different use case to go through. Because I would agree it'd be good to break that out into a different part, right? Because otherwise we get too much going on at the same time.
I think it's worth diving deeper into tracing, not tracing as trace events, but tracing as open telemetry. But I think it's worth mentioning here that it can be used to track down which components are slow.
So the tracing is limited usually in two senses. That one, it's highly sampled. So I'm not sure you will get the exact problem. Another thing is like there are multiple levels what you can capture, and like many companies literally only capture like their own process, like one span, and they don't go into what that process does. So you're just capturing basically downstream service calls. So your service is just a black box, and you will only see that the request started to process and stop process. And some companies capture more, like they are capturing the different functions in their service. But usually, in general, tracing is very focused to the network pattern.
Okay, so for this use case, tracing could be useful to ensure that the slowness is coming from the application and not from a downstream service. Is that what you're saying?
Yes. Yes.
Okay.
So maybe some companies have more metadata, and that can help them, but I think in 90% of the use cases, it can only help you to identify the field.
Yeah, I could kind of see that there's like if you've got a system with a bunch of components, the first step is to use something like open tracing, open telemetry to say, okay, which is the component that's the problem? And then once you've got that, then separately, you've got to dig into, okay, it's a node process, and how do we investigate why it's in particular has this intermittent behavior?
I agree.
So are there others? So there are others. You're saying you thought there was something other than Prometheus? I think that's where we got off onto this.
There is a older tool called Zabbix, which I think companies still use, but Prometheus is still more user friendly. I think you can list only Prometheus.
Okay. There any other? So if you're getting intermittent behavior, if you've got those metrics, you can tell what's changed, what's different in terms of the the traffic, or what's going on around the time of your slowness or your performance issues. I guess still turning on things like the sampling heap profiler, not the heap profiler, but like the CPU profiler, if you can get, turn it on for those periods, would help you potentially also see what's going on.
Yes. In the case that there are increasing CPU, I agree.
Yeah. I guess it would also be good, like looking at the event loop lag. Do any of the tools help you get? I know Node has some APIs to help you get that. Does Clinic display that?
I think Clinic does.
Okay.
But when we are talking about spikes, I think it's more common to investigate in production than in development. Because
Yeah, definitely. So what's the tool? What are the tools that you would see people using?
So if we can confirm that they're using increasing CPU, then definitely the CPU profiler can be used. And I think we covered it already. We even covered 2 ways of using the CPU profiler in the past sections, and I think they apply here as well.
Yep.
So if it's not, it's worth looking at event loop lag, which I think we have on performance hooks, something to determine event loop lags. Yeah, it can be calculated with performance hooks.
Right. Now, is that something, though, that, you know, something there, is there something there we should recommend being pre-installed or?
Yes, but honestly, I'm not familiar with performance hooks, so I don't know exactly what needs to be installed or included.
Right. That I guess we'll need to see if we can figure out. Like, I'm not sure if there even is a module that hooks into those. And
I don't think there is need of a module. We already have a perfhooks.monitor event loop delay, which gives basically what we want here, I think.
you need.
Yeah, I think this one. Are you seeing the document?
Yep.
Okay, cool. So I think performance hooks is the underlying technology that should be used to measure event loop lag and other event loop metrics, but it should be part of the Prometheus agent or the whichever monitoring.
Right. We should be exposing, you think, those. So are they low enough overhead that they can be, like, Prometheus is really just collect metrics, keep sending it out, right? Is it the kind of thing that we can just have like an event loop lag always available?
Yes. I'm not sure if Prometheus if it uploads information or if the agent collects information.
It's usually a collection, like it's in the metrics endpoint that then can get hit. There are some ways to push data as well, but you know the default is you got an endpoint, and every time it gets hit, it provides some metrics.
Yeah, I'm not sure about Prometheus. At Netflix, we use Atlas, which is a monitoring tool we created, and we have a plugin that calculates the event loop lag. I'm not sure how it's calculated. It doesn't use performance hooks yet, but it's definitely something that can be made available via the monitoring tool.
Okay. Yeah, I think you're right. And maybe, you know, something we should consider is like trying to get it in as the default metrics for, you know, Prom Client, which is one of the leading Prometheus, node.js Prometheus libraries.
Mm-hmm.
Or having some, I think we could also, like, it also allows extensions. So having some, like, you know, recommendations on how you extend the data that it reports by default might be the other approach.
Yeah, I think we should take a look at the official, if there is a official Node.js Prometheus agent. So just so we know what metrics to expect.
Yep, the Prom Client is the one that seems to be most used. Like, we've done some, like, from our internal review looking at it, that's the one that we saw as the one we'd end up recommending just because it was widely used and has the base features. So, but in terms of what it provides by default, I don't know that off the top of my head. But that would be good to, like, you know, if we don't have, it doesn't have these things, either confirm that it does have them, or if it doesn't, figure out how you would get them out.
Agreed. I think it's safe to assume that they have event loop metrics. But
things like though, like the event loop lag may or may not be there if it needs an experimental API. But
there are other methods to calculate the event loop lag,
right,
which is what we use on the Atlas agent.
Okay.
But yeah, we should confirm if they have or not. But for now, let's assume they have.
Yeah, let's assume we can get those out for how we recommend you debug, right? Because either it'll be yes, it's there, or here's how you would add it so that you get that in your environments.
Has anyone debugged an application that has event loop issues? Because I'm mostly familiar with CPU. Usually when I look at the metrics, the event loop is not a problem.
Yeah, I'm trying to think the event loop getting longer. I mean, it's sometimes the external dependencies, which we're trying to factor out of this in this case. I guess it could also be CPU though, right? Like that could be a reflection of some things are taking longer and therefore blocking the event loop.
Yes, that's definitely something that can happen.
So it may be that, like, you know, if you're getting, so are there the question is, are there cases where you have an event, like it might be if you have an event loop lag, although the lag I think actually ends up being, that wouldn't necessarily be affected by long external requests. I think it's more, you know, things are waiting for other, they're not getting processed because other earlier things are taking the time, right? Like,
yes, or
is there,
it can, sorry,
go ahead.
continue.
No, go ahead.
It can be because some tasks are taking longer, or because we have too many tasks in the event loop. That's also possible.
Right.
And it's even more possible now that we have promises, because it's so easy to misuse them.
Right. I guess there's that. There's the other one is if you actually do a synchronous call and block the event loop, that would be another potential. Right? Like you actually do something which you wait on you wait for the response synchronously instead of doing it asynchronously.
Do we have any way to trace synchronous calls? A flag or something? Because I think that should be useful.
Yeah, I'm not aware of any way that you can say, yeah, I'm blocked on. I guess you could. I wonder if there's anything that tells, like, I don't know if in any of the performance things, like you could look for things which are like running on the thread for a long elapsed time, even though they're not using a lot of CPU. Right, exactly. So you can kind of like, if you look at it and you see, say through your Prometheus metrics, you see, okay, like if you basically see that you have high CPU usage and a high event loop lag, it's probably best to just look at take the CPU profiler out and see, well, what's using all that CPU, right? Because hopefully that gets you there. If you don't see the high CPU, but you still see the high event loop lag, then you want to figure out what's in the event loop for a long period of time, even if it's not using CPU. And what I don't know is I haven't looked enough at the performance timing API to see if any of those APIs give you that, perhaps, or not.
I don't think we have anything that. Oops. I don't think we have anything that shows if we are blocking on synchronous
Right. Okay.
calls. But yeah, I think it's the only case where you're going to have a high event loop latency with low CPU usage. Like low, almost zero CPU usage.
Yeah, no, I think that's right.
What's interesting is if you have a synchronous call that takes longer than your monitoring agent, longer than the sampling rate of your monitoring agent, that will result in metrics not being reported by your agent. And you're going to see basically unreported metrics.
Right.
Of course, if you have a if your sampling rate is 1 minute and you have a synchronous call that's taking longer than 1 minute, that can be a big problem.
Yes.
But if you're doing per second and it takes 5 seconds, for example, it will stop reporting for 5 seconds any metric related to Node.js.
No, sorry, I have to leave 5 minutes early today, which is now.
No problem.
But I'll talk to everybody later. Bye.
Bye. Anything else on event loop metrics that we can use to identify problems?
Sounds good.
Yeah, I think we should separate from this meeting. We should look into adding ways to identify synchronous calls on processes. Maybe add a trace synchronous calls flag. Anything else on this use case?
Not that I can see.
So when you say identify synchronous calls, do you mean the method JavaScript methods which are not asynchronous but consumes a considerable amount of CPU, like crypto?
No. No, I mean the synchronous calls to external. The synchronous calls to I/O devices, basically. So, for example, trying to open a file synchronously instead of asynchronously, or calling a subprocess synchronously instead of asynchronously.
Okay. Basically, the
Which-
ones which blocks the thread.
Yes, yes.
Okay. Thanks.
I think this use case might also manifest, the spikes might also be might also be caused by swapping. When you swap the memory, you will probably see a spike. If you swap at intermittent, with an intermittent frequency, you're going to see it as intermittent CPU usage, or at least intermittent latency. So checking for swap metrics is also something that users can do. Okay, we have 1 minute left. Is there anything else we want to add to this use case? I think we might want to talk about it a little bit more the next time before moving to the next one. Okay, so I think that's it for today. We meet again next week for the general diagnostics working group meeting, and then in 2 weeks for the deep dive continuing performance use cases, and probably starting another one. So we should decide what we want to discuss next. We can do it in the issue tracker.
Okay.
Yeah, makes sense.
All right. Thank you, everyone, for joining.
Bye.
Talk to you later.
Thank you very much. Bye.